Okay, so today we're going to be talking about linear equations. All right, you guys are probably really comfortable with this stuff. I'm going to show you some solving techniques, but for the most part, I feel like you guys will know how to do this. I just want to make sure you have any questions answered. All right, so really, a linear equation is anything that looks something like this. 4x plus 12 equals 0. 2x minus 1 equals 0. Those are the basic linear equations we're going to look at. And really, a linear equation is any one that can be written in the form ax plus b equals 0. All right, this is what we call the variable part, and this is the real part, okay? Because this is always going to have your variable, mostly x, and a real number. Most of the time when we're looking at these equations, we're going to look for what x value makes this true. What I mean is here, if we have x equals negative 3, we're going to have a true statement. If I plug in negative 3 for x, we get a true statement. We can see this by negative 12 plus 12 is actually equal to 0. Set equal to 0 is true. Here we'd call negative 3, the solution set. Now, I'm not going to be super picky about this, but that is how we'd write the set of all solutions. All right, but most of the time we're just going to be focusing on this x equals negative 3, which is essentially just an equivalent equation as that 4x plus 12. Earlier I talked about equivalent equations. These two equations here are considered equivalent. What we call solving is actually finding an equivalent equation. Most of us already know how to solve equations. All right, but consider something like this. We can do a bunch of operations to get this into an equivalent equation that has x equal. Earlier in the year I asked you, how do you know you've solved an equation? And most of you answered by getting to x equals. There are actually 4 different types of operations we can do to solve these equations. The first one is distributing to get rid of the parentheses and combining like terms. Once we've distributed and combined like terms, we can then add or subtract terms from either side, either the real or the variable part. Here, we can subtract the 3x from both sides to cancel it out. This leaves us with negative 18 is equal to 2x. The next thing we can do is multiply or divide by the same non-zero term on both sides. So here, if we divide by 2 on both sides of the equation, we can cancel that 2, leaving us with x is equal to negative 9. The last operation we can deal with is really one that we've been doing most of the time anyway. We can always switch and interchange the two sides of the equation, so we can end up with x equals like we talked about. This last step is not vital, but does make it a little bit easier to see the answer. And if we want to go ahead and write our answer as a set, we do our curly brackets, draw the negative 9, and answer it as a set of all solutions. Now I'll admit, most of you probably thought that last part was kind of boring, and you've been solving equations most of your high school career. All right, now we're going to get into some stuff that's a little bit trickier, and we're going to deal with stuff with rational equations. Remember, an rational expression was just the quotient of two polynomials, but really, rational tells us fraction. In the last section, we had to find an LCD, change all the denominators, and add things together before we could do anything. But now that we have this equal sign, we can multiply both sides by the LCD and clear our fractions. That's what we're going to want to do, is clear the denominators, get rid of all fractions, and make it an equation that we know how to solve. So here, we can find the LCD, which is going to be 5 times 2x, which is 10x. Notice we only needed that x, that one was already included. So we take our equation and we multiply both sides by the LCD. This gives us a new equation, or one without denominators, and it's going to be a much easier solve. So here, if we look on this side, 10x times x, these x's cancel, leaving us with just a 10. 10x times 5, the 5 will cancel with the 10, leaving us just a 2x. And then lastly, the 10x cancels with the 2x, leaving us a 5, which gives us a 15. Now we've reduced this problem to one that we should know to solve, but just in case, subtract 15 from both sides, giving us negative 5 is equal to 2x, divide by 2, divide by 2. Our final answer should be x is equal to negative 5 over 2. And if we wanted to write this as our solution set, it's negative 5 over 2. All right, but again, I'm good with that. Before we move on, we'd want to actually check to see if our original equation is messed up by our answer. What I mean by that is if we take our x equals 5/2 here, and we plug that in for x's, do we get any zero denominators? As you can see with here, the only restriction is that x cannot equal 0, which does not equal negative 5/2, so we should be okay. Some of you guys might have this down, but let's go ahead and check one more example to make sure we're good. First off, let's check for our LCD. All right, this one's pretty straightforward. The only denominator we have is x minus 3. So our LCD is simply just going to be x minus 3. Now before, we multiplied every single term by that x minus 3. So let's do that here. X over x minus 3. We'll cancel that x minus 3. 3 over x minus 3. We'll cancel that x minus 3. And then the 9 has no denominator, so nothing cancels. So you still have to multiply by x minus 3. This gives us a new equation of x is equal to 3 plus 9x minus 3, where if we were to solve this, distribute that 9 through, and get x is equal to 3 plus 9x minus 27, or x equals 9x minus 24. Here we have a simple solution. We subtract 9x from both sides, and we get negative 8x is equal to negative 24. We divide by negative 8, giving us a final answer of x equals 3. Now, just like before, we want to check to make sure that x equals 3 does not mess up our original equation. Our original equation was x over x minus 3 is equal to 3 over x minus 3 plus 9. But notice that x equals 3 gives us a 0 denominator, and x cannot equal 3. So this simply has no solution, because our only solution available gives us a 0 denominator. The last thing I want to show you is really just an application of the solving the rational expressions. Here we're trying to find all the values for which y1 equals y2. Now to do this, all we need to do is set our equations y1 equal to our equation y2 and solve accordingly. To do so, we need to find our LCD. Now remember, before we do anything with rational expressions, we want to make sure everything is factored. So this expression here can be factored and rewritten, leaving the first part the same. And the second part becomes 4 divided by x plus 6, x minus 2, making our LCD x plus 6, x minus 2. Just like before, we can get a couple little shortcuts to help us with this. When we multiply both sides by our LCD, we really just have to worry about what is missing from the individual terms. So in this first term, we're missing the x minus 2. So it's going to become 3 times x minus 2. This one will become 1 times x plus 6, because the x plus 6 was missing. Here, nothing was missing, so it just becomes a 4. Now we can solve this like any equation. 3 times x minus 2 becomes 3x minus 6 plus x plus 6 equals 4. Combining our like terms, 3x and x becomes 4x. Negative 6 and 6 becomes 0, all equal to 4. Divide by 4, final answer of x equals 1. We'd want to check, but if we notice, that doesn't mess up our original equation of x plus 2 or x minus 2 or x plus 6, so this answer should work. And our final solution set is the set of 1. And what this means is that the value x equals 1 makes the y1 equal to y2.